Welcome to A-Level Computer Science. This presentation will guide you through the two-year course. We'll talk about Unit 1, Unit 2 and the project element. We'll also discuss some of the enrichment activities that are available. I'm going to briefly talk through the main structure of the course. There are 3 units, Unit 1, Unit 2 and Unit 3. Unit 3 I'll talk about in a minute and show you some project examples. Unit 1 makes up 40% of the course, as does Unit 2. And Unit 1 covers contemporary processors, input-output storage devices. We look at software and how software is developed, which is entwined with the programming project because you need to know how to develop software in order to build your programming project. We look at exchanging data. So how do databases work? How does the internet work? And so on. We look at various data types and data structures. So these are things like variables, arrays, graphs, trees, and we explore all those different types of data structures. And then we do a module at the end, which is all about the legal, moral, cultural, and ethical issues that are impacted by computing, the development of AI, the way that technology is changing how we live, how we work, how we shop, our healthcare, and so on. Unit 2, again, is the other 40% exam. It's all about computational thinking, problem solving, logical thinking, looking at programs and how do we develop them to solve problems? Can we find algorithms to make more efficient solutions for problems? It's not just about a particular programming language. We use something more generic called pseudocode. We look at lots of flowcharts and build flowcharts to solve various problems. Unit 3 is the programming project, and we leave this fairly open-ended as to the type of project the students would like to do, so they can select something that they have a particular interest in. We do ask that they complete the project in either Python, C#, or a web-based project using a combination of HTML and CSS with some JavaScript. The project has to have a real end user, and it can be anything from a website for booking tables at a local restaurant to a role-playing escape room type game, or it could be something more hardware based, such as programming a robot. I'm going to talk through a few examples of some of the projects we've had over the last few years. This one on the screen in front of you is a snapshot of a hardware and software project that a student did, which monitored the movement of hospital staff such as doctors, cleaners, nurses, to see whether or not they were visiting sinks to wash their hands before they went to visit a patient. And if they were going to approach a patient before they'd visited a sink, the system would generate a warning message. It's a representation of a current project we have going on in Year 12. Our student has built and soldered a Raspberry Pi robot which has line sensors, and her project is all about building a program that will help a robot find its way around a maze in the most efficient journey. So what's the shortest way they could find their way around the maze? We want to develop that program so that no matter what maze this robot is put in, it will always eventually be able to figure out the shortest route to solving that maze. And then another style of project we've got here is a role-playing game. So this one was about monsters and zombies, and they hid in different rooms and you had to interact with different objects. Different objects would cause different things to happen when you interacted with the different characters. And this one was a really successful game that was really fun to play as well. This again was a role-playing game that a student built. This was based on the Pokemon franchise. And actually I've got a short video of this project in action for you to see. Not only is the computing science course creative and engaging, but it also opens up lots of exciting career prospects for our students. So I've just listed here some of the areas that our students have gone on to study in higher education and some of the careers that our students have gone on to do later on in life. So we do have some enrichment activities that go on as part of the computer science A-level course. In year 12, I encourage all the students to enter the GCHQ Cyber Challenge. This is a multi-round competition that is online and it throws up all sorts of cyber challenges, teaches us a little bit about how to prevent hacking, how to find secret messages hidden in codes, and the students really enjoy it every year. Within the computing department, I encourage our computer science A-level students to take on mentoring roles. This may be mentoring younger students who are studying the GCSE, but also we have a fantastic robotics club for our lower years. And in the past, lots of A-level students have gone on to be team captains and mentors, which is a great thing to talk about on CVs and university applications later on. Every other year, I take the A-level computing students to Bletchley Park and the National Museum of Computing. It's a massive part of the history of computer science and the evolution of technology, and it's a fantastic trip. I hope that we will be able to do this next year or in year 13. Alongside Bletchley Park, I have offered to take the students on some virtual tours this year. So we've been to the London Science Museum on a virtual computing and technology tour. We've also done one at the Manchester Science Museum, and these are things that I'd like to continue to share with the students to give them that real exposure to the evolution of technology over time. Thank you for listening to the presentation. I just wanted to leave you with a few quotes from my current A-level students and the reasons why they enjoy studying the course, the things that it has brought to them, the extra opportunities. Please feel free to ask me any questions.